So in this unit, we learned different strategies, and with identical objects, I would say we've gotten two strategies so far. We've got our spaces strategies, which also lets us count permutations, and now we have our permutations with identical objects. What's hard is sometimes a question isn't as easy to recognize what kind of question it is. And this is an identical objects question that's kind of disguised. Graham walks 8 blocks from his home to the library. So if we draw this out and I get all of my blocks there, he always walks 4 blocks east. So this is his home up here. Here is the library down there. He always walks 4 blocks east and 4 blocks south. There we go. So one thing you could do is you could try to draw all the routes. Okay? So can you see that this route would be one way that he goes? Okay? And we're going to assume that Graham is somewhat intelligent and doesn't get lost. When you're walking from one place to another, he's not going to go, oh, oops, oh, shoot. Oh no, oh there's my house, oh, there's my house again, house, 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 oh there's the library, okay? We're going to assume that Graham can always get closer as he goes because he's always walking 8 blocks. Otherwise, if you circle around, you're going to be walking more than 8 blocks and he's going to get confused. So the hard part is trying to count them all, like this one and then this one. And you tell me if I hit one twice and someone else count them as we go along. Make sure that I haven't done any ones more than once. Are we doing good? Did I miss any?
11, 12.
Well, that's not allowed. Okay, so this is not really a good strategy either. Okay? This is not a good strategy because it's hard to count them as you go along. So we need to figure out, how do we represent this? Like if I pick a route, right? This looks like an easy one to get from his house to the library. How do I represent that? Well, what did he do? He went east, east, then south, 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 and then east, east again. So easy, easy way. That's the easy way to get there. Okay? Can you see that this is an identical objects question now? Because he always needs to go 4 blocks to the east, always needs to go 4 blocks to the south. And so our way of figuring that out, well, 8 letters would normally be 8 factorial, but there's repetition here. We divide by 4 factorial for the e's, 4 factorial for the s's. So if you recognize this as an identical objects question, that each time you rearrange 4 e's and 4 s's differently, you get a different route. Now, there is a way to count this. If you would start here at your home, how many ways can you get to this intersection? Well, there's only one way to get to that intersection. Does that make sense? And there's only one path that gets him to that intersection. If the library happened to be there, you'd be like, well, there's one way to get there. It's just 1 block away. Okay? Now, can you see if the library was right here, there would only be one way to get there? Because again, it's only one path that's straight. And one way to get here, and one way to get here, one way to get here, one way to get here, one way to get there. Because the only way you could get to this corner is with this pathway, which would be straight east. But how many ways are there to get to this intersection? How? Can you draw out all 4? 2. You could go this way, east and then south, or south and then east. How about this one? south and then east, south, east and then south, or east, south, south. This one's going to be 3. And by symmetry, that's going to be 3 as well. What do you think this number is going to be? 4 and 5 and 4 and 5. Okay. But what about this one? If there are 3 ways he can get here and 3 ways that he can get there, he can get to this one by these 3 or by those 3, making it 6. And so that makes this 10 and 10, 15 and 15, and 20, 35, 35, 70, which is the same answer if you've typed it into your calculator already as 8 factorial divided by 4 factorial, 4 factorial. Okay? So you can get questions, pathway questions like this, and they can even be, you can make them even more complicated if you add, on his way to the library, Graham always walks past Sally's house. Oh no. How many ways does he walk to the library now? It's always by Sally's, but how many pathways could he go to Sally's? So now he's never going to go in this area. Can you see that? And he's never going to go to these intersections because then he'd have to backtrack. So we could count it the counting way, right? We could say, well, there's 1 and 1 and 1 and 1 and 1 and 2 and 3 and 3 and 6 and 4, 10 ways to Sally's house. Still needs to get to the library. How many ways are there to this point right here? Still 10. Because the only way that he can get to that is if he takes these 10 paths and goes that way. 10 plus 0, because he's not coming from this one, right? Yeah. And so this will also be 10, and this will also be 10. And 20. And 30. So how could we do something like this one algebraically? Well, it is sort of 2 different parts you have to figure out. He first has to figure out what pathway he's going to go to the Sally's house, and then he needs to figure out what pathway he's going to go to the library. For Sally's house, can you see for Sally's house he needs to go east 3 times and south twice? That would be 5 factorial over 3 factorial, 2 factorial, which happens to be 10, which we already see there. And then he needs to go from Sally's house to the library, which is 1 more to the east and 2 more south, which would be 3 factorial over 2 factorial. That decision has 3 choices. 10 times 3 is 30. So that second part is showing us that sometimes we have to use both of the strategies that we know. Okay, we know identical objects as a strategy. We know the spaces and the fundamental counting principle with decisions and choices as a strategy. And adding Sally to the mix could put both of those strategies together. It could. So questions for this one, or question for this one is number 12.